So yesterday we worked on what do we do if we've got vectors that we need to add that aren't perpendicular or that aren't collinear. Okay, so quick review. If I want to add vectors, the first thing I do is I draw them in what way? Something to something. Yeah, tail to head, actually. Yeah. So we draw a map of what's going on in the particular question. This vector happens, and then this one happens. All right, so we draw them kind of on top of one another. So there's our first vector, and there's our second vector. We draw the tail of the second vector on the head of the first vector. Is that ringing a bell for everybody? Okay, once we get to that point, then we need to find out how far it goes in every direction. Okay, so I need to find the x components and the y components, and that's kind of where we left off yesterday, was finding the x and y of any particular vector. Okay, everybody with me on that? Okay, so if I want to find the horizontal component or the x component of this line, which yesterday we found out was 175 meters, then I've got to use some trigonometry. X is which side? Opposite or adjacent? It's adjacent because I'm dealing with this 50-degree angle right here. So if I want to find the adjacent side, okay, then I use cosine. Okay, so down here, all right, I find the adjacent side. Okay, it'll be, then I'm going to take the hypotenuse, 175 meters, multiply by the cos of 50, and that will tell me that this side is 112 meters in length. If I want to find y, in this case, y is the opposite side. So if I want to find the opposite side, then I'll take the hypotenuse and multiply by the sine of 50, and that will give me that this side is 134 meters, right? And then at that point, I'll have all the horizontal stuff, and I'll be able to figure out how far horizontally the thing goes. I'll have all the vertical stuff. I can figure out the total vertical, and then use Pythagorean theorem along with some trigonometry to get my final answer. Okay, so basically this is what we're saying happens. Okay, I first draw my two vectors, so that would be vector A here and vector B, and I draw them tail to head. Their overall sum, okay, or what we call the resultant, would be C. That's going from beginning to end. It's the one straight line that goes from beginning to end. So in the process of going along A and B, I go horizontally, first this far, and then this far. Everybody all right with that? Okay, as well, I go vertically this far and this far. So I've got all my y's and all my x's. If I want to figure out how big C is, I'm going to take all my horizontals and put them together, and take all my, whoop, just want that one. Okay, so I'm going to put my two verticals together. That'll be the two black ones. Okay, so it'll essentially be like this. Okay, and then I'll be able to figure out kind of what my resultants x and y are. Everybody with me on that? Okay, we did an example of that yesterday. So once I figure out how far horizontally it goes and how far vertically it goes, I have the totals, and I can find, using Pythagorean theorem, how big C is. Okay, so that's kind of what this is showing here. All right, I've got all the verticals and all the horizontals to give me C. Okay. All right. And like we said, once we get to that point, then it's Pythagorean theorem and a little bit of trig. So let's go over this. I want you to, I think you have this one in the notes package, but not a bad idea to write it down so we can kind of walk through the steps together here. Okay, so I've got these two vectors. I've got vector A that's 70 degrees above the horizontal and is 145 meters long. And I have vector B that's 105 meters long and is 35 degrees below the horizontal. Determine the magnitude and direction of the resultant, which is the red line C. Okay. Now, something they've done in this diagram that I probably wouldn't do is they showed the 70 degrees and then didn't draw the triangle to include it. Okay, where did they draw the blue triangle? On the other side. Not that big a deal. It's not what I would have done, but it's not that big a deal. What's the angle inside that blue triangle? 20 degrees. Okay, so that's what we'll do. We'll just not use that 70. We'll use the triangle they drew along with the angle that's inside it, 20 degrees. Okay, no big deal. They just drew it so that it wasn't overlapping. Their triangle wasn't overlapping the diagram. Otherwise, it gets kind of busy looking. Okay, so that's the reason they would have drawn it outside like that. Okay, so if I want to figure out how big C is, I need to figure out how far along the x-axis I go in total and how far along the y-axis I go. So that would be my resultant y and my resultant x. So I've got to find those two numbers. The only way to find those two numbers is to use the vector components of the two triangles that I do have. So we'll start with A, the blue triangle, and we'll find, okay, blue y or AY, okay, and we'll find AX up top here. So let's find AY first. Which side of the triangle is AY? It's adjacent, right? It's touching the 20-degree angle. So it's beside the 20-degree angle. Beside is adjacent. Okay, so it's the adjacent side, which means I'm going to calculate it using cos. The cos of 20 degrees times the hypotenuse, which we were told, I'll write on here, was 145 meters. Okay, so times 145. Now, where did I get this formula from? Remember that this is the rule here. The cos of theta is the adjacent side divided by the hypotenuse. So all I did was solve for adjacent by multiplying by hypotenuse. Okay, so that's where I got that formula from. I just manipulated the cosine formula. Okay. All right, so we'll calculate what AY is. So the cos of 20 degrees times 145. All right, so 136.25543. meters, and I'm going to write that that's positive, because that's all the question gave me was positive and negative, like above the axis and below the axis is positive or negative, right? So anything to the right of the y-axis is considered positive, anything to the left is considered negative. Everyone okay with that? Okay. All right, so next thing I got to calculate is AX. Okay, so AX is going to be the opposite side. So I'm going to use the sine of 20 times 145, and that'll give me the blue X. All right, so 49.59292. Okay, and I'm writing down all the decimals here. I don't normally do that, but I'm writing them all down just so that I have them all, because it is important I keep them all, okay, for accuracy throughout. When do I want to do my significant digits? At the very end. Never round off in the middle of a calculation, especially a vector calculation. You start doing Pythagorean Theorem where you're squaring a number, you square a rounded off number, it makes kind of a big difference because you've lost some decimals, okay? and it'll alter your number. All right, this X is to the right, so that's going to be positive. And now I've got the blue triangle all done. So now I'm going to move on to the yellow triangle. I don't have a yellow marker, so I'm going to redraw it in green, just so that my colors all match here. All right, so if I want to find BX, is that the adjacent side or the opposite side? It's adjacent, right? It's touching the angle, it's beside the angle, so for that one, it's going to be the cos of, this time, 35 degrees times the hypotenuse, which we were told was 105 meters. All right, so that's going to be 86.010. 465 meters, and that is also to the right, so it's positive. Hey, everyone with me so far? Don't be afraid to ask questions as we go along here, guys. Okay, now I have to find how far downwards vector B goes. Okay, so the y component of vector B, and it's the opposite side. So that'll be the sine of 35 times 105. Okay, it is 60.2255. Okay, is that one positive or negative? That one's negative because it's downwards. Okay, so I have all of the x's and all of the y's now. Okay, so what do I do with the two x's? I add them up, okay? Because ax plus bx is going to equal the entire horizontal displacement during this question, okay? And that'll be the x side of my vector c here. All right, so in order to calculate my red x, okay, I'm going to take the other two. So I'm going to take blue x, which is 45.592. I'm not going to write them all there, okay, plus bx, which was 86.010. Okay, I'm going to add those together and figure out what my total x is going to be. All right, so we're going to have 45.59292.078 plus 86.01096.465. Okay, so we've got 131.603 meters. I'm going to keep the full value in my calculator, okay? So I'm not rounding off here. I'm going to keep my full value in the calculator. So that's my total x. For my total y, I have one of them that goes up and the other that goes down. So I can either subtract or I can add a negative. Mathematically, it's the same thing. So whichever is more comfortable for you, okay? That's what we need to do next. So I've got 136.255. Okay, that one's positive, right? And then I'm going to subtract the one that's negative. Okay, so minus 60.2255. Again, I'll use all the decimals when I do that calculation. Okay. We'll double check it. Anybody else get a different number than that? Okay, well, actually, that saves me time because now I have that number and I don't have to type it in. Okay. So, and then I'm going to subtract from that the 60.22552582. All right, so I'm getting a y component that's still positive, 76.0299. Meters. All right, so these two are positive. So now I know the two sides of my total or my end resultant. Okay, that's vector c here. Okay, so if I want to find out the magnitude of c, what do I have to do with those two numbers? Pythagorean theorem. Okay, I've got the two sides of a triangle and looking for the hypotenuse. Okay, so I'm going to plug them into Pythagorean theorem. So C is going to equal the square root of 131.603, of course, with all the numbers actually in it. Okay, squared plus 76.0299 squared. Oh, shoot, I lost all those numbers. It'll work. I didn't say that. I'm going to shortcut here, but you guys would obviously keep all the decimals, but I pressed clear and lost them all and didn't write them down. So, okay. So we're going to have second function here. We're going to square root 131.603 squared plus our answer from the previous squared. All right, so my end resultant, or the magnitude of C, is 151.986 meters. Everybody all right with that? Added these two together. Yeah, like I took the two x's. Okay, so I took ax, which was 45, and I added it to bx, which was 86. Yeah. All right, so there's the magnitude of my resultant. Now, because this is a vector quantity, I also need to find what theta is. All right, well, I know all three sides of the triangle now. I could use whatever trig function I wanted to find that angle, and that is entirely up to you. Tan's my favorite, so I always use it. Okay. So I'm going to go tan to the minus 1 of my opposite side, which for me was the y, okay, because I'm looking for this angle here. So y is my opposite side. So I'm going to have 76.0299, okay, divided by 131.603, and that'll give me my angle. Okay. All right, so I'm getting a 30-degree angle here, okay, 30.01 degrees. Okay, and what do I have to say that the direction of that 30-degree angle is, according to what this question gave me? Except the question it didn't give me any compass directions though, right? It's oriented 70 degrees above the horizontal, below the horizontal, so my reference point has to be the horizontal or the positive x-axis, I could also say. Okay, so either way here, I would go with 30 degrees. Actually, how many significant digits do we have? We have 3 significant figures. So my end resultant answer is going to be 152 meters at 30.0 degrees above horizontal. Okay, that's what they gave me, so that's what I'm going to reflect in the question. I don't really like above horizontal because that doesn't tell me whether it's above the positive horizontal or the negative horizontal. Okay, so I would say in a question I gave you, it would say above the positive x-axis. Okay. All right, everybody follow what we did there? Okay, it's always the same steps. Okay, so let's write down the steps here for solving a vector addition question just so we've got them. All right, so step 1. Draw your vectors tail to head. Okay, that's the first step. In other words, drawing our vector diagram. Okay, once we've drawn those vectors tail to head, we want to also add on all x and y components. Okay, so basically, guys, what that looks like is, let's say I drew, okay, first I drew my 2 vectors, okay, So like this, let's say. All right, so those are my two vectors. Then I would, as my second step, put on my x and y. I would probably also have theta in there. Same thing here. Okay, I would put on x and y. Okay, put in my angle. Right, that's what I mean by add on the x and y components. Okay, as our third step, we need to calculate all the x and y components. Okay, and that's trig. Okay, fourth step. Once I have all the x's and y's, okay, I'm going to add the x's together. Okay, add them together to get the resultant or total x. Okay, so the complete horizontal part of the question. And then similarly, add all the y's. Now, when I say add, do I have to keep in mind that sometimes I might have a negative value? Right, then I'm adding a negative, okay? But we call it vector addition, so we just say add here. Okay, we don't always mean like add them without regard for direction. And that says add y, not addy. Doesn't look like there's a space there. Okay, sixth step. Use your resultant x and y in Pythagorean theorem. To calculate the resultant's magnitude. Okay, and then lastly, calculate the resultant's vector. Okay, and again, that's going to be trig. You can use whatever trig function you want because you'll have all three sides of the triangle at that point. And then check your sig digs, okay, and give me your final answer. Okay. Oftentimes at this point, I have some people who are, fairly strong in math that will ask me this. Wouldn't this be a lot easier if I just use sine law? The answer is no, it won't. Okay. I have people ask that every semester, and I tell them, if you're confident in your ability to get this right using sine law, go right ahead, but I don't recommend it for this reason. Regardless of how confident you are, 98% of people who do these using sine law get them wrong. Okay? It's not that sine law won't work, it's that people don't do it right. Okay? They just don't. I don't know why, but they just don't. Okay? This set of steps, while a little bit longer, is a lot more consistent in getting people the right answer. Okay? The other problem with using sine law is if you make a mistake, there aren't as many steps. And this thing, when I mark it, is based on this method. If I don't see these steps, I can only give you marks for the little bit of work that you have there. And if you didn't do it right, that means not as many part marks. Okay? And what sometimes happens with this is people just make a calculation error. They punch something into their calculator wrong. Okay? And as a result, don't get the right answer. But if you use sine law, you don't have as many steps there for me to mark. Okay? But guys, like I know some people like sine law, but I just don't see people do it right. And I've had some really, really strong math students go through this course and not do it right. Okay? So I would highly recommend you do not use sine law. Use simple trigonometric ratios, sine, cos, and tan instead. Okay? You will get it right a lot more often. It'll take you a little bit longer at first. Once you get good at this and realize that it's always the same set of steps, you can get one of these done in like 6-7 minutes tops. Okay, so I'm going to caution you against using sine law. Okay? I just don't see it consistently done right. Okay. All right, so this is just the notes on what we just did. Okay, so they're all there. I've already explained all that as I worked through the problem, so I'm not going to spend time going over them again. Okay, this is just what we did. All right, we're going to skip over that one. Okay, I want you guys, these ones are fairly easy. Okay, I would like you to do all three of, 1 and 3, because number 2 uses the rectangular coordinate system, which we don't use. So we're not going to do that one. So try 1 and 3. They're just about finding the components. So finding x or y or both for a single vector. Okay, not adding 2 vectors together yet. So on our first one, we are told that the displacement vector is 15 kilometers at 40 degrees east of north. Okay, so I'm going to draw a reference line that's due north, and I'm going to go 40 degrees east of it, like so. Okay, that's going to be 15 kilometers. This is 40 degrees, and then this would be their east component. The question only asks for the north component, which is which side? Which side is the north component? Y. Okay, this side here, okay, which is the adjacent side in this triangle. So to find the north component, I'm just going to go cos of 40 times the hypotenuse, 15. Okay, when I do that, I should get 11 kilometers north. Okay, questions on that first one? How many people are done number 3? Okay, give you a couple more minutes on number 3 then. All right, similar idea on number 3. Okay, we got a snowmobile that travels 65 kilometers at 37 degrees east of south. I always use the second direction as my reference direction. So I'm going to draw a line that's due south, and then I'm going to go 37 degrees east of it. All right, so this will be my y component. That'll be my x component. It wants to know how far east it travels. So am I looking for y or x? X, okay, looking for the one that's horizontal. That's the opposite side in this triangle. So that's going to mean sine of 37 times 65, okay, which should leave us with 39 kilometers east. Okay, so that's just finding the vector components, finding the sides of a vector's triangle. Okay, questions on how that works? In this case, sine got me x. Sine always gets me the opposite side. Okay, because the sine of any angle is the opposite side divided by the hypotenuse. I was looking for the opposite side. So I multiplied both sides by the hypotenuse in order to get that other side. Okay, so it doesn't always calculate x, but it always calculates the opposite side from the angle. Okay, in this case, that happened to be x. Okay, sometimes it's y. Yes, you have to be in degree mode for this, or you're definitely going to get some strange answers. Okay. Okay. Any other questions on how those work? Okay. We're going to skip that one. Okay, I want you guys to try number 2 on here. Make it a little bit bigger. Okay, so give number 2 a try. See how we do. So scale's important on this diagram because this object completely backtracks. Okay, it goes northeast and then goes northwest. Okay, so we have to kind of look at what are we. Okay, so we've got 15 meters at 15 degrees north of east. So my first kind of reference line is going to be east. Okay, and I'm going to go 15 degrees north of it, so it's not a very steep triangle, 15 meters. All right, so there's 15 meters at 15 degrees north of east. So there's going to be my x and my y for that first vector. Okay, then the other part of it is west of north, but only 5 degrees west of north. All right, so I'm going to go, here's my reference line that is north, okay, and I'm going to go just 5 degrees west of that. So here's x, here's y, and this is now 13 meters in length. Okay, and this angle in here is 5 degrees. Okay, so there's what my diagram should look like. My resultant then would go like this. Okay, and I could draw its triangle this way, or I could do it that way. It's just I don't want to overwrite what I've already drawn, so I'm drawing it on the other side. Okay, either way would work. So here's my unknown angle. There's my total displacement. Here's y. Here's x. Okay, so that's what your diagram should look like for that question. Okay, if you're having trouble with the diagram, let me know. I can come over and have a look. Okay, if you get a chance to finish this one over the weekend, that would be great. I'm going to start off class on Monday, walking through the rest of the solution for this one. Okay, so that's what we'll start off with on Monday. Reminder, guys, that graphing lab, okay, that we did is due on Tuesday. I'll put that up on the board, but it is obviously on Google Classroom. Might not be a bad idea to work on that over the weekend. And if you have questions, you can ask Monday. All right, have a good weekend, but not too good.